Okay, welcome to the second part of the periodic table notes. First part we did the groups and families of the periodic table. I really, I guess, identified how the periodic table is organized. Is probably a better descriptor of how the first section worked. Well, in this section we're gonna get a little bit deeper into the individual groups of the periodic table. So we're only going to be focusing on the groups or families, the vertical rows here. We'll start off with the alkali metals. Then group 1A. They are the most reactive elements on the periodic table. They are metals. They're all metals. Hydrogen is kind of oftentimes grouped in with them, but they really aren't an alkali metal. So, but it is grouped in with them because hydrogen also has one valence electron. So, because the alkali metals have one valence electron, they're very reactive, and things are reactive based on its ability to bond with other elements. So these definitely are very reactive because it wants to give away that electron to be more stable. They're very reactive with water. Francium, most reactive element on the periodic table. It is used in World War II as a bomb because they drop it next to a boat and it will blow up when it hit the water and cause substantial damage to a boat as well. So anyway, let's move on. This is just a blank periodic table that I used for the the periodic table coloring activity, which I'm sure you remember doing in class. Ever so much fun. If you have this will be very useful for you when we're going through the different groups of the periodic table. So hopefully you still have this in your notes and you can use this for reference. And if you thought, well, I don't know what these things are colored for, you can always flip back to this page and see what exactly things are colored and why you colored them that color. So, and again, you can flip back to my page and pause it, and this is exactly how the beauty of the video is. You don't have to worry about how fast I'm going. You can keep pausing the video. The second group in the periodic table is the alkaline earth metals. Unfortunately, has a name very similar to the alkali metals. They are a little bit different. They're a little bit harder as far as cutting them or using them. They are not near as reactive as the alkali metals. They are reactive, but not as reactive. So I guess it's just a level of reactivity. Similar or familiar ones to you are calcium in your bones. It's on your teeth. It's a metal. That your teeth are not metal, but it has calcium in them. So same thing with your bones. It has other compounds inside of your bones besides calcium. Magnesium's in fireworks, so that's what this picture here is about. You have the transition elements. These are in groups 3 through 12. Kind of weirdos, the periodic table, because they have the ability to have one or two electrons in their outer shell. That's why they're called the transition elements, because they have the ability to change. The prefix trans means to change, as in a transmission, changes gears in your car. So they tend to be way less reactive than groups 1 or 2, but they are they still do react with things. Iron in particular reacts with oxygen to form rust. You have the boron family. On the right side of the periodic table, I'm going to briefly go back here to the periodic table. On the right side of the periodic table, here you have group 1, alkali, alkaline earth. These are transition metals. They form what's called the bridge between this side and this side. On the right side, we have a trend where the next 4 groups are named after their first element. That will not continue the whole way across the periodic table, but it's kind of an easy way to remember some of them. So let's get back to the boron group. It's called the boron group or the boron family based upon the fact that boron is the first element in it. As you'll remember, the alkali metals and the alkaline earth metals and the transition metals, they all have like these special names. Well, the boron family contains all of these elements here, aluminum, gallium, indium, and thallium. Now, they all have similar properties to boron, and that's why they're grouped into the boron family. They have three valence electrons, and familiar ones to you are aluminum. Or that's the only one that's going to be familiar to you. Gallium is used in I don't know what it's used in. I thought it was used in computers, but it's not used in computers because it has a low melting point. So I apologize about that. Gallium here is has a very low melting point. It's actually solid at room temperature, but if you put it in your hand, because your hand's warmer than room temperature, it'll melt in your hand. So that's what this is. It's pretty cool. You have the carbon group, very important group for life on the planet because almost everything in your body contains carbon. You're a carbon-based organism. Well, not you, but the carbon family has a couple things in it you are aware of. Silicon, it's in computer chips like Intel Pentium chips and so forth. Tin is not that familiar to you. We use aluminum foil now, and some people still call it tin foil, but it's really aluminum foil. It used to be made of tin. And you have lead. Lead is very dense, soft metal. Has 4 valence electrons. Carbon forms diamonds, so that's a very familiar thing to us on a daily basis. Nitrogen family. Nitrogen is one of the most abundant elements on the planet. Makes up 77% of the atmosphere. You breathe it in all the time. It is inert in the human body, which means it does not react with the human body. Plants use it. Plants have to have it. It's vital. It's in fertilizers. That's what this white stuff is. It's in bags of dirt that you buy. It has little white specks in it. That is nitrogen pellets because it helps plants grow. It's what Miracle-Gro is as well. Other things in here that you may be familiar with: phosphorus, another plant fertilizer. I doubt you're familiar with any of these other ones. This is bismuth. Everybody always wants to know what this is. Bismuth. I'm not sure what it's used for. I do not know everything about the periodic table, so that's always confusing to people. I'm very knowledgeable, but I do not know everything about the periodic table. I'd wager there's few people on the planet that do. The oxygen family starts with oxygen. Again, it's like boron. In the nitrogen family, it gets its name from its first element, which is oxygen. Very important in respiration for mammals. We need to breathe it. It makes up about 21% of the atmosphere when it's in gaseous form, but it's also the most abundant element in Earth's crust when it's bonded with silicon. Silicon and oxygen bond to form sand. So sand is definitely the most abundant thing in the Earth's crust. Also quartz. Well, quartz is really what sand is, and most rocks are quartz. And so anyway, other things you're familiar with, probably sulfur. It's what makes matches smell. This is the yellow stuff over here, sulfur. This is polonium. It's a metalloid that's radioactive. That's what the radioactive symbol means. Let's go ahead and move on. Fluorine is the first element in this group, but you'll notice its name. This group is not the fluorine family. This is where that trend stops. You have the halogen family, and the halogen families are the salts of the periodic table. When these things bond with other elements, they form salts. Now, you're very familiar with sodium chloride, NaCl. It forms a salt because it bonds with chlorine. Anything that bonds with the halogen family forms a salt. So when you say salt, it's generically oftentimes just understood to be sodium chloride, but doesn't necessarily have to be that to be a salt. Anything that bonds with these things is technically called a salt. That's why this is called the halogen family, because halite, Halite, is a mineral dug out of the ground that we use as table salt. We dig it out, and it is sodium chloride. And we dig it out of the ground and chop it up in little pieces and put it in your salt shaker. but that's where it gets the name halogens from the mineral halite. So it has 7 valence electrons, very reactive. It wants to get 8 to bond, and fluorine is the most reactive nonmetal. Other things you're probably familiar with, again, chlorine. Iodine in its liquid form is not just this red liquidy stuff. Bromine actually is a red liquid. It's the only other liquid on the periodic table besides mercury. And the last group is the noble gases. And the noble gases have 8 valence electrons, so they do not desire to bond with anything because they already have 8. 8 is the magic number in bonding. They will bond with things if forced to in a lab setting, but they will not stay bonded for long because they really have no need to bond with things. So tend to be by themselves in elemental form, which is a rarity on the periodic table. We don't typically find things in elemental form by themselves. But in the noble gases sense, you do. And it's because they won't bond. You don't normally find sodium, and you don't normally find chlorine laying around. But you'll find lots of salt laying around because it's already bonded. So these guys you'll see only in elemental form typically. Helium, neon, argon is a gas, about 1% of the atmosphere. Krypton and xenon are other gases, and radon is another gas. Radon's a radioactive gas. It's actually cancer-causing. So xenon are the light bulbs here that produce blue light. This is neon here. So anyway, it is another notable thing to note about it is that it contains only non-metal gases. All these are gases. No other group has that. So anyway, that's going to wrap it up. Just going to, I guess I'll just stop it here. But I just want to let you know that this is not the only thing you need to be studying. Hopefully this is going to help. It's another tool. Use your textbook. Look over your notes. You got to put forth the effort to get the grade. So I'm trying to do my part, trying to help you. So hopefully you'll try to do your part and help you as well. All right. Well, I will see you in class.